Professor Scarpelli is full professor of geotechnical engineering at the Polytechnic University of Marseille, and he's going to present a presentation entitled Mitigation the Landslide Infrastructure Interaction by Controlling Few Case Design Parameters. So, Professor Scarpelli, I give you the floor for the presentation.
Oh, thank you very much for this invitation to give a speech in this important first symposium on landslides in Mediterranean areas. I think, I want to thank Giovanni Crosta and Luciano Picarelli, especially. Luciano with his research work and his school, and now with this series of symposia, is a bridge between the knowledge about structurally complex formations in Italy that dates back to Capri Symposium in 1977, and the possibilities of our modern tools for geotechnical design. So it's really a great pleasure to be here today. Structurally, the design of geotechnical structure or infrastructure is strongly influenced by the geology of the environment. And this is particularly true when the geological setting is characterized by structurally complex formation. And according to the definition of that were given by Croce in that symposium, these are geological formations that cannot be simply modeled as a continuum due to their complicated lithological and structural features. Although this was really the case, the strong message to give half a century ago, the message of today is that simplified conceptual models may be used in everyday practice, even for such complex design situations, if we use our capabilities in investigating, describing, and representing the ground with all the complexities they exhibit. So we should use these capabilities in that. So here that's a structure complex clay deposit diffusion in Italy, Pleistocene deposit in Italy, and we know how big are difficulties in building infrastructures in such environment. Before entering to the main core of this speech, I want to highlight some issues coming from the new generation of Eurocode 7, where I've been involved so far for many, many years. And I believe that the new Eurocode represents a significant change with respect to the present Eurocode 7 because of introduction of rock mechanics. Rock mechanics is now a true issue within the geotechnical design code in Europe. Although Eurocode 7 does not account explicitly for complex formation, the new issues such as fissures in grounds, geotechnical property of rock masses so that ground properties shall be distinguished when referred to intact material to the mass in place, influence of geometry and qualification of discontinuities on the property of rock mass are very, very appropriate when dealing with structurally complex formations. So I think we have an umbrella now that can cover complexity of our countries, and especially in Mediterranean areas. So we have to update our terminology. The ground model has been introduced, which differs from the geotechnical design model. It is an important distinction, not always well accepted in all the cultural environments in Europe, but nevertheless, it's a very important distinction. The ground model is site-specific outline. That's the real definition, site-specific outline of the disposition and character of the ground and groundwater based on results from ground investigation and other available data. When we are speaking about ground investigation, we include everything. We include desk studies, site inspections, laboratory and field testings, and monitoring. So this is the representation of the reality, whatever it is. geotechnical design model is a conceptual representation of the site derived from the ground model for the verification of each appropriate design situation and limit states. So here comes into the designer. Before, no, not necessarily, but from when the geotechnical design model has to be conceived, then the designer comes into. And this is a conceptual representation and can be simplification of reality or not a simplification of reality. And we may have many geotechnical models with the same ground models, depending on the design situation. And again, the word complexity is actually entering to Eurocode 7, which is something really, really important. And due to the joint work of Italians, Spanish, and French people, ground complexity is now a word common in the general idea of the Eurocode 7. Enter through geotechnical categories, and then these geotechnical categories impacts on the levels of the ground investigation, the selection of the calculation models, the qualification of designers, the supervision required for the works, and the monitoring. So it's an important aspect. To summarize this bit of the presentation, this is a nice picture taken from Gunilla Franz and Hakan Garin from Eurocode 7 people. And you see that there is a clear separation with this line from the ground model, the geotechnical design model. The knowledge increases from top to the bottom. No geotechnical parameters are in the ground model, but derived values of the parameter of the geotechnical properties are in it. Only I can explain with some time what exactly it means to be a derived values, but these are not exactly the geotechnical parameters for design. So now, according to Delia, the complexity of a geological formation is related both to the heterogeneity to laboratory scale and the structural feature at the scale of construction. We have to investigate both, obviously, to be careful geotechnical engineers. And with reference to the laboratory scale behavior, just to give an example, I want to stress on the first example on the left is the work on this highly tectonized phyllite. It's a heterogeneous material, the response of which is dependent on the proportion between the coarse grains and the relative soft clay matrix. And well, I have seen a presentation about that in the past days, and it is clear that the friction for this material have to be selected according to the proportion of the fines, to the grading. And very nicely, the methodology of using reconstituted samples, reconstituted mixtures can actually help in selecting the appropriate value of parameters or properties with reference to the natural material. It's difficult to be sampled, but nevertheless, we can use appropriate methodologies in the labs to understand what could be the right properties to select. And it is important to see how big changes are when you pass from the grain sustained material to the matrix sustained material. Addressing the at the geotechnical work scale the problem, we have to select one model should be when a geotechnical model must be a continuum model, must be a discontinuum model. Here we use the definitions of before. The ground model is the same. If we look at this excavation, the ground model is the same, but the geotechnical model, which is how to represent for the solution of the stability of this excavation on one side, what is the right geotechnical model to select? An equivalent continuum can hold in this case, cannot for the discontinue on the other side. There is a real examples we had for a deep excavation in the south of Italy along the E90 route. And we can see that for a tunnel cover situation, we have seen that the stability of excavation was ensured up to the very bottom level of excavation, the final one. This is because the presence of discontinuities clearly evident during the excavation were actually made possible the formation of mechanisms in this specific case. And there are, in the paper, there are some indication about that. Again, a similar situation can be found in embankment. We also have had some problems when the ground model was not so clear at the design during the initial design, and we have found that the behavior of the real embankment was very much affected by the presence of unknown discontinuities on the foundation soil. So again, at this scale, the selection between continuum and discontinuum, it depends very much on the constraint and the bedding, the stress state. We have seen today some important reflection of how the stress state can influence the overall behavior of the excavation, and the scale of the problem, of course. The case study I want to address is an embedded retaining wall in stiff jointed clays to protect an excavation not very deep, 6.5 meters high slope. The place is in the south of Italy, again along the E90 European route, and this is the place is called DG21, is a specific segment near Catanzaro. Well, the case study is interesting because well, for such a small excavation, the designer decision was to adopt a very big, very strong wall, retaining wall, made of 1 meter and 2 board piles, and all connected with a strong beam on the top. Well, it seems really a large geotechnical work for such a small excavation. But you see, the slope was not very safe. The slope itself was affected by bedding, by discontinuities associated with movement along the beddings. So we recognize that through the experience made just a few months before with the behavior of these retaining structures at the portal of the tunnel in the nearby. And this is clearly appearing in this from this slide, the problem coming from that portal. And here we have the displacement being measured by topographic survey during the excavation of the wall. These are the evolution of the horizontal displacement during the progression of the excavation, and with tension cracks opening and to make free the advancement of this soil deformation along this slope. Again, the recognition of the ground model was a bit poor at the very beginning, and then it was the experience, let's say a sort of observational method, which is not the right way to apply the observational method, obviously, but the observation that make clear how can be useful to know in advance what is the exact assessment of the ground model at the beginning. And so we had to solve the problem in a very similar way for the tunnel, in a very similar way as it was presented before by Professor Jovicic, with prolongating the tunnel, cut and cover methods, and try with to reduce as much as possible any stress release in the slope. What is very important is that we need really to characterize properly the ground model. And this was done as a consequence of the instabilities and the movement at the tunnel portal. So we had a clear occasion a neat occasion to use any tool, site inspections and geological mapping. Also, I want to note that the geological mapping is again a word which is clearly coming into the Eurocode 7. So good to hear today about that. And at the tunnel front could be possible to make all the observation needed to clarify the ground model, and then also the properties of the ground, the samples at laboratory scale. Obviously, it was necessary to characterize the discontinuities and expecting that the movement could occur mostly along that. We tried different techniques to minimize the strength along these continuities with not very much success, I would say. Here we have a look to the whole picture of the laboratory testing results. We have unstable behavior, brittle behavior of samples, and we could characterize peak strength. We could characterize what we could call residual strengths along the discontinuities. It's nice to see that during looking at the coring from the boreholes, it was possible to have an idea of the position of such discontinuities, but not really directly observable, but just breaking by hands these chords in order to highlight where discontinuities were there. And looking at the profiles of inclinometers putting along the slides, it is clear that some discontinuities are clearly active from these profiles. Values of the angle of friction along these continuities appear to be a bit high with respect to the plasticity index, to the soil plasticity, but well, that was what came out from the results. How manage such complexity in practical design of infrastructures? A possible solution is to condensate complexity in representative geotechnical design models and analyze the problem with the simplest possible calculation model. This is a possibility. And to do that, we want to understand, being the object, the retaining wall, and the questions how these continuities can influence the ground pressure on the wall. Remember that is the problem, how to design that wall. Can we find a simple calculation model for the ground pressure prediction? So we tried to make an assessment by using a finite element model, which is not a simple model, but just a way to arrive to the simple model. And we adopt two geotechnical design models, one homogeneous and one jointed geotechnical design model. Very simple analysis with Lasto plus perfectly plastic soil, more courant kind of model. It's a purely theoretical examples when an earth retaining structure is displaced, artificially displaced into the soils to produce formation of yielding zones at the back of the wall and in front of the wall. displacement are imposed, and the interface elements are adopted for the contact between the structures and the ground, and associated and non-associated flows were analyzed. What is the result of that? We want to be able to understand whether the ground pressures were predictable with such a model in an appropriate way. There was a cohesion in the constitutive model, so indeed we found that no ground pressure on the active side, mostly. Perhaps displacement here were not enough to introduce to put the soil to an active state, but we were quite satisfied by the results in general to try a bit confidence on the use of this model. Then we introduced discontinuities, and this was quite interesting because we arranged discontinuities differently oriented to see what could be the influence on the wall, and then we discovered the hot water. That means that when the bedding is in favor of the formation of yielding, then the ground pressures increases pretty lot. And despite the disturbance induced in the model by the presence of discontinuities, we can see that clearly from this graph, we go towards the very high pressure, active pressure, more or less 5 times the pressures that we have in the previous simple homogeneous model. Well, other things can be useful to know, but I want only to stress on the results of the application of such modeling on the active sides, not influence when the bedding is favorable, horizontal, or a negative angle. Largely influence when the bedding is unfavorable to safety, I mean, and at the passive side is moderately influenced by the bedding orientation. This is for the yielding mechanism, so to understand what could be the zone of influence around the wall. Air pressures, at the active side, the pressure distribution is strongly influenced by the presence of the bedding at any orientation, even when it's negative, when it's favorable, I would say. At the passive side, the pressure distribution is influenced in a bit less, 20% of reduction of passive strength, passive pressures in general. So what is the message here? Is basically that to account for the presence of discontinuities in the model we have, we can consider an effect on the ground pressure by representing damage. Basically, having introduce a lot of damage with all these discontinuities where actually interrupted the continuity of the model, and introducing this damage, a continuous model with damage with a reduction of strength parameters, let's say, could be enough good for the purpose of design, not more than that, of course. So ground model includes discontinuities not favorably oriented at the active side. The geotechnical design model considers zones with different geotechnical parameters to account for the influence of discontinuities. So we want to implement in a very simplistic, if you want, model with a spring reaction calculation model with limits, and we assume different strength parameters in different zones. So our geotechnical model, design model, is zoned. How is zoned? We assume residual state zone and the active size above excavation, a critical state zone at the active size bottom of the excavation. Why a critical state? Zero to have zero cohesion there, but displacements were not enough to reduce friction to residual values, and peak zone on the passive side. Here displacement, here not great influence of displacement of the original values. What is the results? What are the results? Ground pressures here goes very typically higher than the active side, then the active solution, we more or less the ground pressure is close to K naught. So it means that the pressure is pretty high. Obviously, the mobilized soil pressure at the passive region is much far from any limit state to be reached. Horizontal displacement are those represented in these graphs, and these are the results. We captured only those are from monitoring. We are capturing only the shape and not certainly the amount of the displacement. But this was not really the interesting aspect of the model, because our goal was to understand what could be the ground pressures on the structure, other than to assess exactly the displacement. We are not in urban area. We don't need to understand exactly, to have a good prediction of displacement. The order of magnitude is important, but not the exact prediction from such a simple model. It's not the right model to predict displacement, of course. Same thing, zone geotechnical design model used for global stability verification, and again, active side, residual strength zone in the upper layer, critical strength zone in the bottom layer, at the passive side, at peak strength zone. So this zone, this is the global stability around the retaining structures, and this could be a possible way. So conclusions. Design of geotechnical structures in structurally complex formation can be efficiently solved by careful selection of geotechnical design models. Besides assessment of stratigraphy and groundwater, the following are above all the key tools for the objective: careful assessment of the patterns of discontinuities with the definition of the ground model. The ground model should be very, very carefully assessed. Material properties, specifically the shear strength of the ground for intercritical and residual state conditions as needed. So all tools that we perfectly know that are needed, but perhaps when we design, we forget about all this. The next generation Eurocode 7 is a step forward for design practice, as well as a great protection for designers. I want to say that, thinking to the presentation we heard yesterday about the big excavation which was falling down, that's, I mean, it's clear that what we need is really to have also protection as a designers about that. So we need to enforce the use of, to consider complexity in the ground when geotechnical design models are conceived. And this is a tool to interact with the owners of infrastructures in order to ask for a good geotechnical investigations for assessing the ground models. Thank you very much for your patience, and I close.
Okay, thank you very much for your very, very interesting presentation. As you mentioned, that's a key point because it shows the complexity of our job when we are faced with, I would say, reality faced to modeling. And you mentioned, I would say, that's clear, the importance of the ground model to protect the designer, because at the end they are responsibility. So that's very, very interesting. You were saying that geotechnical design model are conceptual model, but I would say that's a ground model. You start a conceptual, you start a virtual representation of reality as well with the ground model. Conceptual representation start with the ground model. That's difficult, of course, but that's you point out very, very interesting question regarding responsibility, regarding how we have to proceed and how we need to have very clear and as accurate as possible ground model for, I would say, stressing after the limit condition to be capable to design, to have good design in terms of geotechnique. If there are any questions for Professor for his very interesting presentation? I do hope that there are already people here. I know we are close to
Lunch.
to the lunchtime, but I would say I would be very interesting if we could have questions, because once again it was a very, very interesting presentation.
Thank you.
Introducing, I would say, a very key question in our job.
Yes, I'm waiting for questions. If you want, I can just reply about ground model. The way in which it is conceived within Eurocode 7 at the moment, but it's not a definite decision, because it will be it is an ongoing discussion about that. But the ground model wants to be the representation of reality. And so you need some conceptualization, of course, to represent correctly. Anyway, whatever when you represent, you can conceptualize. But try to be as much as possible to avoid any interpretation when you do that.
Okay, to avoid any interpretation, I guess it's not possible, of course, but
I would say try.
And because you mentioned that, even if you have a very clear and strong methodology to follow, you need experience. So it means that you have interpretation, and even starting for the ground model. But once again, it's a difficult domain, difficult, I would say, process. And as we mentioned, the objective being to protect the scientists, to protect decision making, and to protect the responsibility of the designer. They have to take their own responsibility, of course, I would say, within a general framework. But once again, when you have a model, it's never the truth compared to the reality, and you have to protect people against the consequence that may occur. Of course.
I've got a question from Caterina Di Maio, but I don't know whether I reply on lively. The question is the ground model the geological model? Well, it's something more, really. It's something more. Because it includes, it's not only the description, geometrical description of the ground. The geological model could be a different scale for the ground model. The ground model is already thinking to the object of the design anyway, and it must include the results of ground investigation, all the ground investigation, not ground investigation for geological investigation, but ground investigation for geotechnical purposes. Yeah. So it's something more, and it is a new concept. And but I think that this concept is a consequence of the experience we have been doing in complex soils, and we're trying to reverse this experience within the Nordic understanding of geotechnical engineers for the Nordic countries. So we have a great battle in that, and I think I'm very jealous of conserving these concepts as much as possible. And that's it.
Sorry, the discussion about this presentation is programmed for the afternoon. Now we need to pass for the paper hours.
Okay.
I think that we should change the chat room.
Yes, but anyway, I would like to thank again Giuseppe Scarpelli for his presentation, which was once again very, very interesting. Thanks a lot.
Thank you, Professor.